And hello, everyone. My name is Vic, and I'm from the line Taiwan. I'm as a security engineer, and I'm glad I have the chance to standing here to share the attack vectors in the blockchain application named EOS. And this is my table of content. First, I will introduce about the blockchain and what is EOS. And after that, I will introduce several attack vectors and then the conclusions. So let me introduce myself. And as I mentioned, I'm from Taiwan, and my research field is about web security, mobile security, and the blockchain security. So, and I have been some of the speakers of Huang or the blockchain technology. So, before we start, I want to know about how many people here know about the concept of the blockchain or the features. And I will shortly introduce about the features. We have three features in the blockchain concept. The first is immutable. The transactions which are packed into the block can be changed. So you can see the transactions on the past blockchains. So, and the next is the decentralized. There's a lot of nodes on the blockchain, if you know, and there's different consensus algorithm you can lead you to do something different between the nodes. And the third is anonymity, and the anonymity is about we don't know who is the owners of the wallets. The wallet only present a series of hash. So we have three generations of the blockchain. The first generations begin in 2014 when Bitcoin gets online. And at the first, it's about 10,000 Bitcoins can exchange for $2 of pizza. So it's like very low price at the first. But after that, people start to admit the cryptocurrency are not only a series of bytes in the network, and then the concept of the proof of work is more people knows about the proof of work, and a lot of people try to be a miner in Bitcoin. And then the second generations of blockchain is about the smart contract. And here's the mark of the Ethereum. And the most important thing in the generation 2 is about the software developers, because the smart contract can be written by the developer themselves. But at the same time, because developers make mistakes, so there's a lot of attacks start to shows on the generation 2 blockchain. So if you heard something about the DAO attack on the Ethereum, it's about the reentrancy attack, and first force the Ethereum to fork their chain to Ethereum and Ethereum Classic. And the generation 3 of the blockchain extend the domain into the like IoTs or other domain, and some of the generation 3 application is aimed like this EOS is aimed to improve the problems with generation 1 and generation 2. So this is our topic. First, what is EOS? So the, EOS is his founder is Daniel Larimer, if I didn't pronounce wrong, and it's a Block One CTO. And the important thing of the EOS is it has like 20 times faster than the Bitcoin in block generations and the larger throughput. And the consensus algorithm is used is named DPoS. It's a weak decentralized mechanism. And if I make a example, we can say that it's the DPoS is like a Congress systems in a country. So you have to vote for 21 super node. We call that block producer, and the block producer will deal with the transactions to examine the transactions and make it correct. And the voted 21 block producers gain 50% of the mining profit. And it also emulates the real computer systems. So there's some features of the EOS. It has a virtual resource for the EOS user. And the first two is CPU and net, as you can understand, it's CPU and net. It's used for when you sending transactions, you have to use the CPU and net. And the third one is the RAM. The RAM is the main storage in the EOS system. So, and you have to buy RAM at first because you will write some variables or some data into your RAM. So you have to buy it at first. And here's an example. If you have 13 EOS, and after you buy your RAM, you have 13 EOS, and the free-flowing amount of EOS is only 12 because you have to stake 1 EOS for CPU and net, so you can transfer some monies or do some transactions to other accounts or contracts. So, and also you can unstack the CPU and net you use, but it's only it needs 3 days to decrease the using rate of the those unstacking CPU or the net. So here's a small contract on EOS. It's written by C++, but it seems a little different from the as usual. So if you want to push action, it means you want to do something, interact with another contract. You have to do like push actions. So what is this instruction do is to call the high functions in the hello smart contract and with the data named Bob. So it's So yes, so in the function high, you will call you will say hello to the username. So after the execution, the result will be like this. Say hello to Bob. And here's several types of actions. It's the features on EOS. It's the inline actions and deferred action. But I want to discuss about it next. So here's some types of the EOS DApps. And according to this Acro EOS, the largest kind of the DApps is the game. And the most of the EOS assets is in China. So, and you can see the left hand side. Here's the top 5 EOS DApp in September. So you can see a lot of games and gambling things on the top 5. And so here we'll begin to talk about the security. So here is a security event and news in 2 years, because the EOS is begin from the 2018. So here's the statistics of the packet shell. From packet shell, it's over 113 events and about 1 million EOS news in 2 years. And if we say that 1 EOS is for 3 US dollars, and so we can say we lose 3 million USD dollars in two years. It's quite horrible things. And this is the appetizer. If you look at this smart contract, you'll see if you can read the vulnerable here. It's overflow, easy on-site integer overflow, and this caused a lot of the loss. So we are going to introduce some attack vector. The first is the rainbow table attack. But before we explain about the rainbow table attack, we are going to discuss about how to get a wallet for EOS. And there's EOS JS -ECC is original generators and released by the official company. So they said if you use the generator with the correct seed word, if you are familiar with the MetaMask, it's the same. You have to insert the seed word, and the generator will generate key pairs of private key and the public key to you, and you can use it as your wallet. And the second one, the EOST, is a China project. They just import the tools into a website, so you can when you view the website, you can push like one button, you can create your own key pairs, and so you can use the EOS wallet. But there's people report that their key pairs are reported as used or error, but after they dig in, it's because they insert the null seed word, or like the same seed word. So the private key will be duplicated. And that is a critical problem. So as a hacker, how can we abuse the tools? Through the news about the null seed word lead to the same key pairs. So attacker can use a dictionary or tools to automatically generate the list of the common seed words, key pairs. And the example is about like the brand of the beer. So when you generate the list like that, and here's a private key and public key pair. So this EOS blah 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 is the public key is your wallet address. So after we generate the list, we scan the whole EOS. It's like you can view some transactions on the EOS X. It's like a ether scan or something. So if you find someone's address, it look like that EOS 221IS. So you will know that his private key is this one, because the same seed word generates the same key pair. So So because of this kind of attacks, the EOS lose about $2 million US. And this is the announcement of the block 1. And it's a screenshot. So, and what is a blacklist? We have to discuss here because we have to know what is a blacklist. It's about, because when you send the transactions, after you broadcasting the transactions to the nodes, the block producer, as we mentioned, the super node will confirm the correctness of the transactions, and only over 76% is like 15 super node is confirmed the transaction is legal, and they will pack the transaction into a block. So the list, the blacklist is will be placed in the block producer. So when they see the transactions contain from the blacklist account or to a blacklist account, they will just reject the transactions. So the transactions will roll back, and it will roll back to the previous state. So we're talking about another vectors of attacks. So here's background knowledge of the fake EOS attack. First, we have to know about the apply function. And what is apply function? It's an incoming action handler. And the logic of the code in the apply function will deal all the actions between the account and the contract, and it's in the interactions, and write some data to EOS database. But here's some side effects. That's when you accept actions from another account or contract, it may generate a new transactions. So it's like something like the usage of the apply function. So here's example of the apply function. It's the very old version of it. So we can see here there's 3 variables you have to fill, and here's the filters. When they receive actions, they have to pass the logic. So it will the data will pass to the EOS API. Means it will pass to the function the other people call. So if we push actions to a contract named test with a function high, so this is the instruction we call the test and high. So in the test apply functions, the receivers will be test, and the code will be test because it code the test function, and the action will be high. So this is if you want to transfer some money from you to a contract, here's the thing to deal with the transfer. The important thing is here, if you transfer from the EOS token, there will be a receipt to send to the both side from and to. So the flow is account send transfer into the EOS token. This contract is built on the mainnet. Mainnet. So the EOS token will send both sides the required recipient is like the receipt. And actually, if you want to be a developer, you should customize your apply function so you can deal like more and more different transactions or different requests. So if we receive transactions from Alice to Bob, there and from is Alice, to is Bob, and it's about 25 some symbol, and the last field is about you can write anything in it. It's like a memo. So when we look at the apply functions, the receiver will be Bob because the Bob received the actions, and the code will be EOS tokens because they call EOS tokens to do the transfer things, and the action is transfer. So when the Bob received this actions, it will call the transfer itself. So after it call transfer and then you will call the stop balance and add balance. So after we receive the recipients, the payer sub the balance and the receiver add the balance. So also we can create our own tokens by like instruction like that, and you can use your own symbol, but it's only you can transfer the real EOS on only EOS.token. So here's the two graphs. There's one fake EOS and another is the real EOS, and the left side is the true EOS because if you see in the like Etherscan or EOSX, there's no like comment in the back side. So this is like very easy to understand. The variable is very easy to understand. Hackers create 1 billion EOS, the same name as the EOS tokens. So and it's sent to another account and try to exchange to the other crypto concurrency in the DEX. And what is DEX? It's a centralized exchange. It's like a platform you can exchange the crypto concurrency. So he exchanged the fake money to the real money, and then he changed the real money back to the real EOS. So he gains like about the 40,000 the real EOS. So this is a way we deal with that kind of fake EOS attacks when we receive the actions in our apply function. We should check if the code the caller is from EOS token, and only if the caller is from EOS token and the action is transferred, the money named EOS is the real money, and and this code means if it is not the logic like this, it will be fail. It will be errored. Like you must transfer the real EOS. But the attack is transformed, and here's the EOS bet. It's a gambling games on EOS, and it's like the top one EOS in the 2018. So it's lose about 40,000 of EOS. So we look at the vulnerable apply. So this is when we receive actions, the apply will deal with it, and if it's about something about transfer, it will transport the code into the transfer, and the transfer function will deal with it. So what is the vulnerable code in this page? Because we found that in the transfer, this function, there's no variations of the caller. So if we can guess the function name and the variable here, so we can directly call the transfer. And this is the attack flow. Actually, hackers, the first kind of attack is account can directly use the push actions to call the transfer functions in the smart contract. So he used the money inside this game contract and transfer it to the apply, and you use its own money as base money. So the hackers don't have to spend like even some EOS, and he can play the best game. And another way is like this. Because some of the transactions have the auth check, so it can be called from directly by some anonymous accounts. So if you have used the smart contract to send the EOS once, it means you have the authority to play the game. You can use something like that with the inline actions to call the transfer in the smart contract. So how to fix the problem? So we can see this side. If the code is from self, it means the smart contract itself, and it's from EOS and it's on arrow, so it's going to deal something. And but if the code is from self and the transfer, the code is from the code is from the EOS, and you should prevent to let the non-members of the contract to call your functions. So, and then another problems pop up when we look at the transfer function. As we know, the transfer data is from self is like reasonable because the data is passed by the apply functions. So how can we exploit it? We try to, the attackers have two accounts of EOS. So he can transfer one from A to B and get the required recipients, but he sent the required recipients to the victim contract. So the victim contract see the required recipients is from the account A. So he's misunderstanding because he think in the logic he think, oh, the account A sent me about the bit money, but actually the recipients is for A sent to B. So it's like sending the wrong receipt to the smart contract and it hacked. So I'm sorry for my bad English. I'm like very nervous. So next topic is about broken random numbers. The first is about the rollback. The rollback mechanism on the EOS happens after you sending the actions, like sending transactions and before the actions were blocked. And if the block producer checked the transaction and it contains some illegal code or the blacklist content, the whole transaction will be rejected. So how can we abuse this mechanism? In traditional gamble construct, they use inline functions to check the answer and the transfer. It means they use the series of actions, and if one of the action is arrowed, the whole series of action will be rolled back. And with this kind of mechanism, actually you can let the player knows the results like very fast, but it occurred some problem because if one of the actions in a row is arrowed and the whole actions will be rolled back. So as a player, we don't want to like gambling, but we waste EOS or we have a wrong guess. We only want rewards. So here's a concept. How can we force to roll back if I lose? This logic is about you can check your balance. If I transfer my best money, and after that my balance didn't increase, it means you didn't win the reward, and I will force it to roll back. So the whole flow is that we use an account, and first we get a balance to check my balance, and after that we transfer to, we call the EOS token to transfer the EOS to the vulnerable DApp, and the DApp will apply after applied and transfer, and it receive the receipt. So it will reveal the results. So if it's correct, if you guess, like you're gambling, you will guess the correct dice points, you will get the reward. So you will call, if the attacker is right, you will call the transfer and give the reward to the hacker's account. But here's the thing: we had mentioned about the attack to force a rollback. So what we do here is we send a lot of inline actions to play the game. But if we check our balance didn't increase, we just make a rollback. So we can try it like thousands of times if you have enough CPU or net, and it have no cost because the inline function is roll back. So you didn't have to pay anything. So here's the attack. If you send the upside is if you send transactions but you fail, and you this kind of error message is about you force it to be rolled back, and at below this is the one I assess because I send the transactions to the contract and I guess the right number. So with these two combines, every time we lose, we roll back, and we only accept the results when we win. So how to fix this kind of attack is, first is you can put the hacker's address to a blacklist. It's something like stupid way to deal with it. And another thing is we can use deferred action for the rival. Deferred action is when you send deferred action, it's about you send an action to book another action, so it won't be in the same block. So, but we still can bypass this kinds of protection if they just put it in the block list, because we have a blacklist account, but we can create a proxy contract to make the transaction to the DApps. So still we bypass the blacklist, and we can do the same things. We send inline actions for rival, and if we lose, we roll back. And here's another kinds of attacks. How to bypass the blacklist and at the same time use it. If I have a blacklist account, so I build a proxy contact to send the inline transactions to the DApp, but we just write the blacklist accounts in the from field. So when the transaction is broadcast, the DApp gets the transactions and deal with apply function. It will still send the results, and it's sent by the deferred action. It means it will book actions to send you reward. But actually, when the block producers see these inline actions, the transaction will be rejected because it contains the blacklist account. So here's the thing: you don't have to pay anything because your bid money inline actions will be rolled back, but you still can get the reward from deferred actions. And the next is in 2019 is another attack. And before we talk about the attack, we have to explain the transaction states. And as we mentioned, we can force it to roll back, but there has several kinds of fails to make it roll back. First, like the soft fail. The soft fail is when it's the logic you didn't pass in your code, so it's caused the error. So this is the way we use in the attack way we mentioned before. We force it to while 1 is not equal to 1, it's caused a soft fail. So next is a hard fail. And what is a hard fail? If we can do something like that, the first we make a timeout transactions. You can write like a sequence of a code in the transactions, and after you execute it, it's like takes so long time, so the whole transaction is expired. And next is the code error. The code error is you write an infinite loop in the transactions. So when the block producer see the infinite loop, you will directly reject your deferred actions. So and so on. So this kind of ways you can make hard-failed deferred transactions. So how we use the hard-fail to proceed the attack. First, some contracts said, okay, here's a lot of inline actions attacks, so we force you to use the deferred actions for transfer the bet money. So here's an example. You use the deferred actions to transfer the money, and you use the proxy contract to transfer to the variable contract. So, you can send several times. So if you didn't make it, the result is you didn't win it. You just make it hardful, like you run it into the infinite loop, and because the book actions and the deferred actions you trigger later is the book action. Even the book actions is error. The deferred actions will still go on, and if your deferred actions fail, your origin book action is still there. So it's not the same state as the book action and the deferred action. So you can use this kind of features to make it hard fail when you are losing some money. So the next is the transaction congest attack. So we have mentioned about two kinds of inline actions, and the features of the deferred action is you can book actions and it will be triggered after like sometimes, and when the deferred actions error, the original actions won't roll back. So this is the usual distributions in the blocks. You can see there's some deferred transactions, and some is this orange one are the inline transactions. So, and here's some contract can trigger the deferred actions. You can see the blue one. If you set the delay second is 0, it won't be in the book actions, and deferred actions won't be in the same block. And there's the features of deferred actions. You can replace the existing deferred actions. So you can generate, you can book deferred actions for generate another deferred actions. So here's the things we can do the low cost DDoS, because the deferred actions, it has a higher priority to the block producer. It means the block producer, when they pick the transactions which are going to pack in the block, the deferred actions will go first. And the second one is the deferred actions can produce a new deferred actions. So, but if we want to send a lot of actions, we need a lot of CPUs. But if we make it hard failed, the CPUs will return to you. So this is abnormal distribution. If we try to produce a lot of deferred transactions, and it's produced more deferred transactions, and some of them are just we're going to hard fail. So we use these two kind of features. We can almost like DOS the whole blocks. It's like DOS the whole chain. If the all of the transactions in a block is like illegal. So when the vulnerable is found, the block one hard fix it. You have to be like half and half between the different transactions and the inline transactions. So it seems the transaction congestion attack is just some kind of DOS attack, but actually it works on some gambling games because some of the gambling games, they generate their random numbers by the entropy is used the informations on block. It's like block numbers or block something, but actually that kind of information is you can control. And how to control? You can use a lot of the transactions to make when the different action for the rival to place the rival different actions and your actions in the same block. So if you know how to calculate the random number and you are in the same block of with the rival actions, so you can guess the numbers right. And here's the attacks just happened in September. They use the REX. The REX is some kind of resource exchange source to prevent the transaction congest. So it buy a lot of cheap CPU and net, and it send a lot of different transactions to the variable contract. So the contract the rival of the different actions will be expectable in some block in the future. So maybe I have no time, but yes, it's like a lot of content, and I'll just say about my personal opinions about the blockchain security issues. And the first things you have to use the consensus algorithm well. For example, if you want to develop some project in the EOS, you have to familiar about the DPoS, the algorithm they use, the features, and you have to understand the mechanism and the features on the blockchain concept. It's like the basic concept, because some developers just ignore the concept, so they make mistakes. And then you should double check the smart contract, and to, maybe you can ask some companies to do the smart contract auditing. And the rest of two is only my opinions. If you can design a mechanism to raise the risk of the payment of the actions, it's like the game theorem, because hackers don't want to lose money. The hackers just want to earn money. So if you make a mechanism that he has to pay a lot more than he gained when he is doing something bad, the hackers won't try to do this. So, and the last one is military policy, but it's about the real money, the interest rate added, like the rate up or rate down in the real money, but actually it's centralized. But we have the good example of this applications on the blockchain is named Maker or MakerDAO, and it's the concurrency named DAI. So it has a pretty complex mechanism to adjust the real money between the real money and the cryptocurrency. So it begins on the 2018, but it's still very stable, and it's equals to like almost $1 USD price. And if you know about the blockchain security events, there's a lot of attacks on the blockchain. So as example, the EOS is like over 130 attack events in 2 years, but this one is MakerDAO is like stable. So because of the mechanism, the basic mechanism is used. So that's why the MakerDAO it can be still stable and safe. So I think this is my speak. So thanks for listening.
Well, thank you very much, and a round of applause, please.